Hello students, this is a review for Exam 3 for Math 0306. Exam 3 covers Chapter 7, Factoring Polynomials, and Chapter 8, Rational Expressions and Equations. Chapter 7 is a review of some material covered in the previous math. We're reviewing factoring, and we'll need factoring also in Chapter 8. So basic concepts in Chapter 7 for factoring polynomials include factoring out a greatest common factor, factoring polynomials by grouping, factoring polynomials using the AC method, factoring by patterns, and solving quadratic equations by factoring. In Chapter 8, the concepts covered for rational expressions and equations, we will simplify, multiply, and divide those. We will add and subtract those, including those expressions that do not have common denominators. We will solve equations including rational expressions. And we will work some applications including those over proportions, variations, distance, and work problems. So let's start with Chapter 7. And a problem where we want to factor the greatest common factor. So we're given this polynomial here, and it's always good to count terms when factoring, when looking at a polynomial. This polynomial has 1, 2, 3 terms, and so we're looking for the greatest common factor. So it may be helpful to think of each of the coefficients in factored form. So I might start by looking at the smallest coefficient. I see here that 6 is the smallest coefficient, and I might think, is 6 is a factor of itself, of course. Is 6 a factor of 24? Yes, it is. Is 6 a factor of 30? Yes, it is. So it looks like for the coefficients, 6 is part of the greatest common factor. Now we're going to look at the variables. Well, let's look at the x variable. We have x to the 6th power, x to the 4th power, and x to the 7th power. Well, the smallest factor there is x to the 6th. I'm sorry, the smallest factor is x to the 4th. Alright, so is x to the 4th a factor of x to the 6th and x to the 7th? Yes, it is. We can always take the smallest power or the lowest power of a common variable as part of the greatest common factor. So x to the 4th is part of the greatest common factor. Now let's look at the y variable. Y to the 3rd, y to the 6th, and y to the 6th. Okay, so it looks like the lowest power or smallest power of the variable y is y to the 3rd power, or cubed. So we know that that will be part of the greatest common factor. So the greatest common factor is 6x to the 4th y cubed. Now we're factoring that out from our 3 terms here. Factoring means we're dividing it out. So as we rewrite the polynomial, we're going to factor out or divide out this greatest common factor from each term. So when we factor out the 6 from 6, we're left with 1. And 1 would be a coefficient unless it's the only part of our term here. We don't have to show the 1. So we'll leave it understood for now. When we factor in x to the 4th from the x to the 6th, we're dividing out. So remember, when we divide same bases, we can subtract the exponents. So that means factoring out an x to the 4th from x to the 6th, or dividing x to the 4th from x to the 6th, we could subtract the exponents. 6 minus 4 for 2. When we factor out y cubed from y cubed, well, that divides for 1, doesn't it? We factor out all of the y cubed. So our first term factors out as x squared. Our second term, we're factoring a 6 from negative 24. That's negative 4. We're factoring in the x to the 4th from x to the 4th. That cancels to 1, leaves a factor of only 1. When we factor y cubed from y to the 6th, we subtract those exponents. That leaves us y cubed. For the third term, when we factor 6 out of 30, divide 6 from 30, that leaves us positive 5. When we factor x to the 4th from x to the 7th, we can subtract those exponents for x to the 3rd, or cubed. When we factor y cubed from y to the 6th, we can subtract those exponents, and that leaves y cubed. Now we can check the remaining polynomial here to see if we think it will factor again. But after some trial and error here, we can see that this trinomial is not going to factor. And so we have done our job here. We factored out the greatest common factor. Okay, let's look at another factoring problem here. The instructions say factor completely, and it's a good idea, remember, to count the terms. So how many terms do we have here? 1, 2, 3, 4 terms. And do all 4 terms have a greatest common factor? That's what we check for first. Do we have a greatest common factor? No, not for all 4 terms. Okay, so if we don't have a greatest common factor for all 4 terms, then we can try to factor by grouping. That means we can take the first 2 terms and then the second 2 terms, one group at a time. So if we look at group 1, 4 and negative 2x, they share a factor of 2. They'll both divide by 2. So a common factor for these 2 terms, or for group 1, is 2. When we factor out the 2, 4 divided by 2 is 2. Negative 2x divided by 2 gives us negative x. For group 2 now, we're going to start group 2, or we're going to take the common factor out with a negative because group 2 starts with a minus. So we'll bring that down. And then 30y and 15xy, well, we hear that the y is common. 30 and 15 will both divide by 15. So 15y is common to group 2. And because we brought the negative down, it's negative 15y. So remember, when we factor out a negative, it will change the signs here. This will become positive, and this will become negative. So negative 30 divided by negative 15 is positive 2. Y divided by y is 1. Positive 15 divided by negative 15 is negative 1. Let's see if we have to write the 1. Let's see, the y divided by y is 1, and that leaves only an x. Alright, now factor by grouping continues here. We check to see if we have a new common factor. Alright, so these are factors here, and these are factors here, and it looks like the 2 minus x is a common factor now. So 2 minus x is a common factor, and when we factor that out from the first term, divide this out, we have only 2 left. When we factor that out from the second term, we have only minus 15y left. Okay, now 2 minus x, 2 minus 15y. Good idea to include our equal sign at the beginning of each line to show that we're writing equivalent expressions in a different form. Okay, let's look at another factoring. factor completely. Okay, let's count the terms here. This polynomial has 1, 2, 3 terms. And so when we have 3 terms, because we remember the process from chapter 6 when we were multiplying, many times when we multiplied or when we FOILed 2 binomials, we were able to, the result would be a trinomial. So when we're factoring, we're often thinking that a trinomial might factor into 2 binomials. At this level, we don't spend much time factoring or remembering how to factor trinomials when the first coefficient is, or when the leading coefficient is 1. So we're going to practice some when this leading coefficient is something besides 1. So a very handy tool for factoring this kind of trinomial is the AC method. So let's remember the AC method says we need to label A, B, and C. A is 12, B is negative 29, and C is 14. And the AC method says that if we'll make a table with a column for AC and a column for B, AC says that we're multiplying A times C. So 12 times 14, 12 times 14. Let's see what that's. Looks to me like 168. And B is negative 29. Now, we need factors for 168, a pair of factors that will multiply for 168, and the same pair needs to add for negative 29. Alright, so 168 is a rather large number, so it might help us to see what factors are in there. We could go back to the 12 and the 14 and say 12 is 2 times 2 times 3, that's 12, and 14 is 2 times 7. So that might help us pair up factors. Let's see, what numbers have a good chance of adding or subtracting for negative 29. So let's see, 2 times 2 times 3. Well, we don't think 12 and 14 would work. 12 times 14 works, but 12 plus 14 does not give us 29. Okay, you could start with those and hope for the best. So 12 times 14, 12 plus 14 adds for 26, not 29. So we have to try some other pairing of these factors here. So let's see, 2 times 2 is 4, times 2 is 8, 3 times 7 is 21. Now I just lucked out right there. 8 and 21. 8 times 21 multiplies for 168, and 8 and 21 add for 29, but we need a negative 29, don't we? So what about if I make these both negative? They will still multiply positive, and the same pair over here will now add for negative 29. So that just gives us the pair that we're going to use. So remember that when your leading coefficient is not 1, this does not produce a drop-in pair for your 2 binomial parentheses. What this does is produce a pair so that you can split the middle term and then use factor by grouping. We just reviewed that. Okay, so we're going to split this middle term here. So now we have 12s squared. We're going to split the middle term minus 8 SD. It will have the same variable part as the middle term here, minus 21 SD, and write our third term, which is now our fourth term, since we split the middle term into two. Okay, now we're going to factor by grouping. So we're going to look at group 1, and we see that 12 and 8 share a common factor of 4. S squared and SD, the variable parts, have a common factor of S. When we factor that out, we have 3S minus 2D. S's cancel. Group 2, we know it's going to be a negative common factor. Group 2 starts with a minus. 21 and 14 have a common factor of 7. SD and D squared have a common factor of D. When we factor out negative 7D from group 2, we get 3S and negative 2D. And now we need to look at the new terms here and see if we find a new common factor. Yes, we do. 3S minus 2D is a common factor. And when we divide that out of these two terms, we have what remains, 4S minus 7D. Alright, and then we check to see if those will factor any further. And we don't have any more squares here, so we believe that that's factored. Now remember, you can always check your factoring by multiplying. Okay, this is now factored, so you could FOIL this and make sure that you get this back to check your factoring.